All right, the first part of this video is an introduction to vectors. And we're going to be looking at vectors in a plane, scalar quantities, and vector quantities. And I want to compare two statements for you. The first one is, the distance between 2 points A and B is 6 miles. So this particular statement, the distance is just what we call a magnitude. There is no direction indicated in this statement. When we look at the next statement, an object undergoes a displacement of 12 miles due east from a point A to point B. Now this statement gives us both the distance between A and B and the direction. So the first statement basically indicates what we call a magnitude, or what we call a scalar quantity. When we talk about displacement, we're talking about both magnitude and direction. So when we have a description that gives us both magnitude and direction, or a number that describes magnitude and direction, these are called vector quantities. And so lots of quantities in geometry and physics, like area, time, and temperature, can be represented by just a single number. Other quantities, such as force, velocity, force and velocity, involve both magnitude and direction. So they can't be represented by just a single number. So in a few minutes, we're going to be drawing some vectors, but right now, just a quick description. Really, to indicate a vector, you draw what's called a directed line segment. It'll have an initial point and a terminal point. The magnitude of a segment is going to indicate its length. And so when you just want to talk about a vector, the line segment itself, you just have PQ with this little arrow over it, indicating a vector. The magnitude, which is actually the length of that line segment, is going to be indicated by this symbol here, where you've got the double bars on either side of the vector. Also, when we draw vectors, we can use a single letter, V, or W, or U, but we would use that in, we'd write that in bold. Now, when you're writing it yourself, it's really hard to show bold. So on a computer, if you're using a word processor, you can use a bold letter V, or any letter, but it should be in bold to indicate a vector. If you're handwriting it, you're going to look at that letter and you're going to draw the letter with just a little arrow over it. Right? So just the notation here. Vector V is the same thing as this V with an arrow over it. The magnitude of V, you could show a bold-face V with the double brackets here, or the V with the arrow over it. So I'm going to draw a couple vectors and show you a couple different scenarios here. The first scenario is two vectors, V and W. And since I'm handwriting them, I'm using the V with the arrow. It's kind of a half arrow. And then the W with that arrow. Now these two vectors have the same direction and the same magnitude. So they're considered equal. So two vectors with the same magnitude and same direction are considered equal. The next two vectors have the same direction, but they have different magnitude, meaning they have different length. So we've got equal vectors. Now we have two vectors that have same direction but different magnitude, so you draw them basically with the same angle to the horizontal, but a different length. All right, vectors can have different direction and different magnitude. So these vectors drawn here, not only are they have a different angle that they make with the horizontal, but they're also a different length. These two vectors right here have different direction, right? So the angle that they make with the horizontal is different, but the magnitude is the same. Their lengths are the same, but they're in different directions. And then the last scenario is really just a special case of this prior one. We're going to have two different vectors with different directions, the same magnitude, but they'll be opposite. So these two vectors right here, They have the same length, so the same magnitude, but they are pointed in opposite directions. So one vector is the opposite of the other. And as long as the arrows are pointing in the same direction, if the slope is the same, then we know that the direction is the same. So we can use slope to help us find the direction of two vectors. So the first thing we want to learn how to do is just to show that two vectors are equal by looking at the magnitude and direction. So we've got steps here to show that two or more vectors are equal. So we want to find out, in order to find the magnitude, we just need the distance formula. We want to find the distance between those 2 points. And to find the direction, all we need to do is find the slope. All right, so I've indicated the initial point, okay, and the terminal point. So we're starting at -6, -2, and then we've got this terminal point, -2, 3. So the first thing I'm going to do is use the distance formula to find the magnitude. To refresh your memory on the distance formula, the distance between 2 points, x1, y1, and x2, y2, is the square root, basically, of the distance between the x's squared, or the difference of the x's squared, and the difference of the y squared. So just like when evaluating slope, the order in which you do this doesn't matter as long as you're consistent. So I'm going to call this point my first point, x1, y1. And then we'll call this point x2, y2. So I'm going to take my x's. So I'm going to have -2 minus -6. I'm going to square that. And then I'm going to add that to 3 minus a -2. And I'm going to square that. I want to name the vectors. So let's call this first vector u. We'll call this second vector v. And so what I'm really, this distance here is actually equal to the magnitude of my vector. So the magnitude of u, evaluating that square root, we get the square root of 41. So the magnitude of vector u is equal to square root of 41, which is basically the length of that vector. Now I'll find the slope of that vector just using the slope form. Since both of the vectors are pointing up and to the right, if their slopes are the same, then we know we have the same direction. So if I do change in slope is change in y over change in x. So I've got 3 minus a -2. There's my y2 minus y1 all over my x2 minus x1, -2 minus a -6. And we do that calculation and we get 5/4. So the magnitude of u is square root of 41 and the direction is 5/4. Now let's do the same for vector v. The magnitude of vector v is going to be the square root of 4 minus 0 squared plus 5 minus 0 squared. Which equals the square root of 41. And the direction, just look at the slope. It's going to be 5 minus 0 over 4 minus 0, which is 5/4. So we can see here that the magnitude of vector u is the same as the magnitude of vector v, and the direction or slope of vector u is the same as the slope or direction of vector v. So therefore these two vectors are equal. And just use some caution when using the slope to determine if the direction of two vectors is the same. Because remember, they have to be pointing in that same direction as well. So if I could draw two vectors, here's one, it would be my vector u, and this one would be vector v. So the slope of those two vectors is the same, but you can see one is pointing up and to the right and the other is pointing down and to the left. So in order to use the slope to determine if two vectors have the same direction, you have to make sure that those arrows are pointing in the same way. Which is why later on we're going to spend more time talking about vectors in terms of a magnitude and an angle. All right, so I've indicated the initial point and the terminal point. So what I'd like you to do is pause the video and find the magnitude and direction of each of these vectors and show that they're equal. And we'll indicate that this first vector will be u and this second vector will be v. So the magnitude of vector v is going to be the square root of 2 minus 9 squared plus negative 7 minus a negative 3 squared. When you evaluate this, we're going to get the square root of 65. Again, we'll just leave this exact for now. And when we talk about direction, we're going to have net 9 minus a 2 and negative 3 minus a negative 7. And that's going to give us 7/4. So we've got the magnitude of vector v, which is the square root of 65, which is basically the length of that line segment, and the direction, which is the slope. Let's do the same for, that's vector u. And now let's look at vector v. All right, when we evaluate the distance formula to find the magnitude of vector v, we get the same thing as the magnitude for vector u, which is the square root of 65. For the direction, we find the slope between the 2 points. So we get 7 minus 0 over 7 minus 3. So our direction is going to be 7/4. So these two vectors are considered equal. Now notice, two vectors don't have to be in the same exact place to be equal. Right? They just have to have the same magnitude and the same direction.